Good morning, students. We are discussing the extra points related to the resistors in parallel. 5 points already we have discussed, only 1 points are there. Next one is ratio of the potential differences. Ratio of voltages or potential differences across the resistors in parallel. Potential difference V is equals to constant per combination, therefore the ratio of the voltages is equal to 1:1:2. In series combination, current ratio is 1:1:1, parallel combination voltage ratio is 1:1:2. Next point is important for the competitive exams. It is current division or called as branch currents only for CV. Other cases also we can use, but you avoid using for the theory examination, short form like direct form like that. Branch currents. Branch currents in resistance or for resistors in series in parallel. Or in the case of resistors in parallel. This case we take out 2 resistors only. For 2 resistors in parallel, we take as for 2 resistors. Not 3. 3 are there means you take 2 later. Branch currents for 2 resistors in parallel. Direct formula. To find out the branch currents through the resistors in terms of the main current. We have taken the voltages before division for the series combination. Here we discuss is parallel combination, current difference plus minus V. Resistance R1, resistance. Total current from the battery is say I. This I is divided into parts I1 and I2. I is divided into parts I1 and I2. I coming to the junction. If resistance is more, current will be less and vice versa. Okay. So that current I is divided into parts. I is supposed to be equal to I1 plus I2. And resultant resistance becomes is R1 R2 by R1 plus R2. So single resistance if you consider as equivalent resistance. Same battery, same total current. This is a resultant resistance. R parallel is current I. V is equals to I into R parallel. What is the resultant resistance is nothing but equal to resultant R parallel equal to R1 R2 by R1 plus R2. Only for 2 we have to. More than 2 means 1 by R parallel equal to 1 by R1 plus 1 by R2 and so on we have to take. What is same for the parallel combinations? Voltage is same. That means V is constant. V is also equal to I into R parallel. V is also equal to I1 R1. V is also equal to I2 R2. V is same for parallel combination. Same battery for both. So V is same. So V is equals to I1 R1 is also equal to I2 R2 is also equal to total current I into R. So you are asking for only I1, only I2 from this relation will get. Okay, I is the main current through battery. I is called as the total current or main current. Main or total current through battery. Main or total current through battery. So if I want I1 now, just take the relation to this. I1 R1 is equals to I into R parallel. R parallel is this here also. What you get is I1 R1 is equals to I into R parallel is R1 R2 by R1 plus R2. So here R1 cancels. I want branch current I1. So I1 is equals to I into R2 by R1 plus R2 is the relationship. Similarly, if I want I2, you can write this simply. If I want I2, no, total current I1 is the same. R1 here. I1 means R2 numerator. I2 means R1, that you can remember. But voltage is not like that. Voltage is required in series combination. V1 is equals to V into R1 only here. But denominator will be total resistance. But branch current formula is applicable only for 2 resistors in parallel, not multiples. If multiples are there, 2 you need to take, but generally we don't take that. Similarly, I2 is equals to I into R1 by R1 plus R2. You have to remember these two formula. I1 comma I2 are nothing but branch currents. That what I say, branch currents in terms of the total current. If I take n resistors in parallel, then what about the current ratio is equal divided. Resistance is same, more resistance, less current. If resistance is same, current is also same one. So what you get here is this resistance R1 R2 same means what I1 equal to I2 also same. So total current I is supposed to be equal to, in this case I is supposed to be equal to I1 plus I2. If the R1 is equal to R2 if you have taken, then I2 is also equal to I1 only. So that way it is 2 I1 only. Similarly, if I take 3 resistors in parallel, if I take 3 identical resistors in parallel, all resistors will have the same current. So I equal to I1 plus I2 plus I3, 3 I1. All currents are same. N resistors are in identical parallel. You get is n times. N times I1 is equal to total current. Two identical resistors R1 equal to R2 equal to R0 in parallel. Then I1 is equals to I2. I1 is equals to I2 and total current I is equals to I1 plus I2 becomes equal to 2 I1. For n identical resistors in parallel, identical resistors in parallel, what you have the current becomes is divided equally. So total current I naught, current through each resistors. Current to each resistance, the total current is a total equal to n times equally divided. These all electrical devices in the houses are connected in parallel only. So some fans may take more current, some fans may take less current, bulb may take different current, power of the depending on the power of the bulb they may take the more current, less currents. Okay, that means what if they are connecting these devices in the house, all are parallel only. What is said for all the devices parallel is V is same voltage comes from the power supply, but currents will be different. The one which has more resistance take a less current and vice versa. If all are same 100 watt bulb, 100 watt bulb you have taken all, means identical resistance. So each bulb current will be I naught if you have taken means the total current is equals to n into I naught, equally divided for all the devices if they are depending on their resistances, more resistance or less resistance. So devices will be taken marked up with the different voltages and also power we discuss later. Depending on the resistance we can calculate and we can calculate the current they can consume. And for parallel series combination, I didn't discuss voltage division for identical resistors. We have discussed already what is the resultant resistance only, but I want to discuss even this voltage division for identical. This is an extra point only, mainly for the numerical statement. identical. We take as Ni. Then identical. Resistors in parallel. Voltage or potential difference is equally divided. Voltage is equally divided. Sorry, not parallel. Parallel array I discussed, no? In series. In series, voltage is equally divided. Series combination. Like this, if you take n resistors, R1, R2, R3 and so on, all are same values, are not identical. This is nth resistor. Current is same. So total connected to total battery voltage V. V divided into parts V1, V2 and Vn. Whenever the identical resistors are there, no, all are equal. V1 equal to V2 equal to V1. So, but this is equal to sum of the voltage only. So, V is equals to n times V1. V1 is equals to same voltage if you have taken. R0 is each resistance. Each resistance. I is current in all same. Current same in all. V is the total voltage. V1 plus V2 plus and so on plus Vn, which is equals to n times V1. All identical. V1 is equals to V2 is equals to V3 quota and so on equal to Vn. For identical condition is not identical resistors only. Therefore, V total equal to n times V1. And already resistance we have taken. R total is sum of the resistance will be n times R. So V1 becomes equal to V total by number divided. Where do we use this? Generally we don't require, but sometimes if you require that voltage is battery is more than the device it can withstand. Okay. A bulb is given to you, it can withstand only to the voltage of 100 volts, but you have 230 volts in your house. If 230 volts is connected to 100 volts now, the voltage is more than required for this, the current will be more than it can handle. The result is that filament will be heated up and melts. Melting point crosses that because the temperature is increasing. Whenever the current is increasing, current is nothing but flow of electrons only. These electrons collide with the atoms of vibrating atoms. But if the collision number is more electrons colliding, the heat temperature, loss of kinetic electrons will convert into heat energy, convert into finally increases temperature. The final result is that electric energy converted into heat energy. If the temperature exceeds the melting point of the metal, then it melts. That means we must limit the current related to that particular material. So finally, current depends on the voltage in these cases. So voltage is not actually affecting anything. What affects us is flow of electrons. That means current actually. It's a bulb brightness of the bulb, the speed of the fan, all rate the currents at particular voltage that current is affected, of course. But it is the current which is affecting here, voltage is pushing on the electrons. So in this case, if you take this as a 100 volts bulb is given, 100 volt, I am telling 100 watt, not 100 potential. Watt means power, volt means potential difference. So 100 volt bulb is given to you, but here voltage is 230 volts or 200 more than that. And direct 230 volts means the bulb will burn. First, before burning, it glows more brightness than required, but finally ends up. So to avoid what it is, you have to divide this into parts. Then what you have to do is this total volt divided by this already 100 volts resistance is their filament resistance. Take one more resistance in series, or you take one more bulb in series. Two bulbs you are taking means what 100 means what happens is total voltage is 200 volts or 230 volts divided into two parts. If you take 3, divide into 3 parts. So each bulb will get less voltage than the total voltage you are providing. So in such case, if the device is not able to withstand the required voltage, then you connect some resistance in series. Other device or other electrical resistance you have to take, some electrical wire, 9 kilo wire, etc. You can connect in series of the specific resistance you have to take. So that the total voltage V is equals to V1 plus V2, and for the device the voltage will be less than what it can work or equal to what it can work and less than the total voltage, so that the device will not damage. So voltage is divided, series combination. Series bulbs generally you will find now we are using LEDs. These LEDs light emitting diodes, they consume less current and they work with the 12 volts generally. For that purpose, they are using one adapter to convert these 230 volts into DC 12 volts. DC or AC, they work for both devices. LEDs. 12 volts, there are connected in parallel ways. LEDs now coming, no, they are connected in parallel. In the olden days, they used to use the small electrical bulbs near the functions or temples, etc. They used to connect all the bulbs in series. Each bulb works with 2 volts to 6 volts. That means directly if connected to 230 volts, all will burn on parallel connecting. So what you have to do is all hundreds of taken. 230 volts means you take 230 bulbs in series. The 230 volts divided by all, each one will get only 1 volt, 1 volt, 1 volt. So like that we can calculate how much voltage we can divide it to work accordingly, and then these two connect in series. That time they were using like that, but now we have got LEDs, and then the adapter comes with that LEDs, light emitting diodes. They are all connected in parallel, they are coming, and parallel connection with the same voltage of low voltage is coming, not with the load, step it down with the help of the electron device called the rectifier. We are going to step down transformers, we will discuss that later. That comes in the later topics. Next is electric power. E and electrical energy. Electrical energy. Symbol is taken with E, or U symbol is used for this electrical energy. Okay, capital U, not small u. Capital U is a symbol for electrical energy. And E also used, but don't get confused with the electric field also symbol is E only used. So E is multiple cases are used for the different cases. Next we are going to discuss electromotive force EMF. That is also E is used. Any of the symbols, but don't get confused with the energies. You word use energy or not, because just seeing E, don't think electric, don't think the electromotive force, or don't think some other symbols. Electric field is different. Energy symbol is also E. Most of the cases, some other cases we use U also, capital U also. So be careful with the symbols. Here, what is the battery cell actually? Cell. About the cell I have discussed last one topic, but basic point, just points out. Cell. Cell means actually enclosed from all sides is called a cell. Closed room is a cell. This room is also closed from that all sides, that is called a cell. Cell means it is something which is closed from all, the enclosure. Enclosure or the room which is closed from all sides. So if you take the cell, is used in biology also. That is a cell. It is as a cell walls, closed from all sides, so it is a cell. And even jail, that is also called as a cell only. That because it is closed from all sides. And battery is also called as a cell. This cell contains electrolyte. Cell contains electrolyte. So are based on some liquid state will be there, or the paste like, but wetness is compulsory, not dry ones. Dry cells name is also used, but they are not dry cells. In the houses, what we use for the battery cells, you will find value or written on it as 1.4 volts. That is not a electric voltage. It is actually called as electromotive force. Total voltage a cell can provide. When it can provide the current, no, maximum voltage it can provide is called as a EMF, called as a electromotive force. It is not a force. Its name is a force, but it is not a force. But it is something which pushes the electrons to move. It is like forcing the electrons to move. So the name first was taken as electromotive force only, but it is not a force. It is nothing but a voltage, potential difference. It is nothing but voltage. But which voltage means? It is a maximum voltage cell can provide is called as a voltage with the two terminals. Every cell has the two terminals, plus and minus. So you find this tip, maybe metal finding, but actually inside what you find is the carbon rod will be there, and it acts like a positive electrode. Okay. And zinc content will be there. I am talking about the cell. I am talking about the cell. We are using the houses. That's not the dry cell. It's not actually dry. Inside contains ammonium chloride and manganese oxide. Paste will be there inside. And this zinc acts like a negative terminals, plus and minus. When you as long as this is not connected to the circuit, not connected to the circuit, not connected to the resistors devices, no, it's an open circuit. Current cannot pass the open circuit. So instant chemical reactions do not take place. But otherwise, once you close these two terminals by conductor, then electrons are able to pass now, close the circuit. So ionic reaction takes place inside. Positive ions go one side and negative ions go other side. Inside there is electrolyte, positive and negative ions both will be moving. But outside conductor only electrons can travel. In the conductors only electrons can move, not positive ions, only negative charges. Electrons only travel here.
but positive charges will be going in here in this direction is positive ions, this side will get is negative ions. And these two going in opposite direction produce the current for us and also produce the potential difference. But whenever the current is passing through this cell, now you don't measure this as 1.5 volts, the voltage what you are going to measure now is less than 1.5 volts. That is called the terminal potential difference. I am going to discuss these definitions, so they are important ones. I will discuss again later. Here, but now just basic point I am giving for the cell. These two terminals means end point. Terminal means end points. The two terminals of the cell, if you measure the voltage when current is passing, I cannot have some bulb here. Bulb has a resistance. This is a resistance. Bulb has a resistance. Filament of resistance. Okay, that means bulb current is current resistance only. So current is passing now. Electrons are flowing from minus to plus. Conventional current goes from plus to minus. Conventional current indicates direction of motion of positive charges. So you have to imagine everything. Every time in this physics, we talk about the positive charge motion, positive only we think. Okay. Here, these ions, positive ions go like this, but here we get only electrons. Electrons only moving in the conductors. The total voltage is called the electromotive force when current is not passing. Okay, and the resistance inside this material, the chemicals are present, electrodes are present, they have the resistance, that is called internal resistance. Inside resistance is called internal resistance, symbol is always taken smaller, always smaller symbol is taken. Outside sometimes we take R or smaller, capital, everything, R1, R2, etc. Small can be capital, but internal resistance is smaller in general, most of the cases. So total resistance becomes equal to R and R. Wherever the resistance is there, voltage divided. So total voltage is how much? 1.5. 1.5 voltage divided by the two resistors coming in series to the current. One is capital, another one is smaller. Current is same in both. So I into R is the voltage across the outside. I into smaller is the voltage across the internal capacitor. This internal is not visible to us. It is inside, not visible to voltage drop. What we see is only outside. So what you are seeing outside voltage itself now we are measuring is I into capital. This is less than 1.5, right? Because 1.5 is the total value. Then when you get the 1.5, 1.5 volt is nothing but equal to I into capital plus I into small. So if you include this also, you get the total voltage. So this is the actual total voltage called as the EMF, electromotive force, which pushes the electrons and makes the current to pass through external resistance also, internal resistance also. And this is a cell. Cell is the electrical device which converts chemical energy into electrical energy. And whenever the current is passing through this conductor, electrons collide with the atoms, loss of energy takes place, converting into heat energy. Okay, heat energy. That's called dissipation. We are going to use the term called dissipating, means absorbing. This resistance absorbs the energy, the metal, whatever we have providing here, absorb this electrical energy and converting into heat. Whenever the heat and the metal is made at the high melting point, then finally the temperature increases to high value, and that heat energy converted into light energy. So bulb is a device which converts electrical energy to heat to light. Okay, directly we say electrical to light vehicle. And a cell is an electrical device which has a stored chemical potential energy, stored, not in use. So that is converting into electrical energy. So it can convert chemical energy to electrical energy. So it is doing some work in pushing the charges. Electrons charges are pushed outside. So whatever work we are doing is the definition related to potential difference only we take now. Now coming back to actual points. Electric power. This battery cell symbol we take only plus minus bigger than and smaller than. So I am taking this simple circuit of the cell. I am not talking the electromotive force right now. We take only the potential difference V plus minus. This current is I. So potential difference we already take the definition as flow of the charge means current means flow, current flowing means charges are in motion. What is the potential difference we defined already is 1 by charge. Then that time first topic we discussed, potential, second topic potential. That work done to move a unit charge from infinity to a single point in the electric field is called the potential. And one point other point within the electric field, the work done to move the unit charge. This charge you not have taken there. Unit charge if you have taken means the work itself is the potential difference we take if you are going from one point to another point. Here cell always provide the potential difference only. So it is actually delta V, but we are not going to write every time delta V, we just write a V only. Sometimes written also it is not problem. V is the potential difference. So this is also delta W. Delta W is also equal to small work done to move the small charge also we can calculate. dV, dW also we can take, delta V, delta W also we can take. So what is the work done now? Work done is nothing but equal to V into 2. That means for this cell connected to across the resistance R, potential difference of the cell now we define as potential difference of the cell is defined as work done to move unit charge across the resistance connected outside. This is called the external resistance. Because inside the cell also resistance is there, we call it chemicals are there inside, that is internal resistance. This is external resistance, means outside ones. So we call it as a potential difference V is defined as work done to move unit charge through the external resistance. Work done to move unit charge through external resistance, or charge Q we can take. If it is not unit means V equal to W by Q. Okay. So what is the work done becomes is V into Q. Whatever work is nothing but equal to energy only. That means to do the work we require energy. That means battery is using its own energy to push the electrons from one end to other end. Finally they come back again electrons. Electrons go this like this. They keep on moving like this. The velocity is very slow. Already we discussed the drift velocity. Drift velocity is the order of 10 to the power of -4 meters per second. Means 0.1 millimeter per second approximately. So that means it moves very slowly maybe. And it takes some hours to come back. But finally what they are doing is they are moving in a complete closed path. Okay. And conventional current exactly opposite direction. So whatever work we are doing is nothing but because of the energy only. That means this is work itself is we take it as a energy. Energy used by the battery is nothing but equal to Q into V. Okay. Next is what is the power? Power is nothing but equal to work by time. Power is equal to work by time. The basic definition of the mechanics you learn. So what is work equal to VQ? V into Q by T. But what is Q by T? Charge by time is nothing but current only. So this is nothing but equal to V into Q by T is I. This is the formula V into Q. So electric power is nothing but the product of voltage and current. And V equal to IR formula we have from Ohm's law. R is the resistance value or filament resistance, etc. Otherwise the resistances. V equal to IR substitution, you get the different forms from these expressions. Okay. So that these points again I will discuss. If not completed, I will repeat this in the next class. Time is over means this point will be repeated in the next class. V on current is potential difference of cell. And one more thing I forgot to tell you is battery. Battery is nothing but the collection of the cells. Cell, one cell. Okay, battery means what is more than one. So the current is this like this, plus to minus, minus to plus. So if you want to get more voltage, we keep on connecting many cells in series. Okay, then voltage will be added V1 plus V2 plus V3. About the cells in series, we discuss again some parties in the next class we will discuss. So this to get the more voltage, more currents, we take the cells in combination. So this is called as a battery. Battery means collection of the cells. Even mobile phone actually if you have to say battery take out, no, that is not the same. Inside parts will be there. They are contained in series. So each actually they are rechargeable cells. In the house digital set only they are not rechargeable. The mobile phone cells are rechargeable. They are called secondary cells. Secondary cells can be recharged. Primary cells cannot be recharged. So the secondary cells what we are able to recharge means again you send the current back into the again extract the current from it. Just like the capacitor. But capacitor battery cells difference is there. That we will discuss later. And here if you connect the several cells in series, you can add the voltages. Actually rechargeable cells voltage is 1.2 volts. So if you require more than that, 1.2, 1.2, 1.2. What you get is 3.6 volts. The battery will be having the 3.6 volts for the mobile phone generally. And if more is required, they are connected further in series. So this is called the battery. Batteries means collection of the cells to get the more voltage and also get the more currents. So R is external resistance. External resistance connected to parallel to voltage. I is current. One time. So what happens is current is passing through this. Work done by the battery to move charge Q in closed circuits. In closed, compulsory current has to move means circuit needs to be closed. Closed means it can come back to starting point. In closed circuit. through resistance R
is